So if we have a cube, it says sides cubed. So if I have a cube, that means all the sides are equal.
Yeah.
So when you think of a rectangular prism, it's length times width times height. Well, if they're all equal, it'll be 6 times 6 times 6, which is 6 cubed, which is 216 cubic. And let's say these are inches. It's cubic inches when we're dealing with volume. When you think of volume, you're thinking of filling up this room, how many cubic feet or inches or units you can do. The next volume one is a rectangular prism, and it's basically length times width times height because the numbers could be different. So let's say the width here is 2, the length is 8, and the height is 6. You just multiply those three together. If this is centimeters, then it would be centimeters squared. So it would be 16 times 6, whatever that is.
It's 92.
92 centimeters cubed,
Sorry, 96.
So it's 96
Yeah,
centimeters
96.
cubed. Okay. A prism is the most confusing, I think. This right here is a prism. And I'm going to try to draw one. I'm not good at this. Okay? And that would be the same as this one I have here, made out of a copy paper box. Okay? If you look at this prism in reality, then you're looking at 3 rectangles. Do you see them? Rectangle, rectangle, rectangle. Pay attention up here. And 2 triangles. Got it? Whatever you have 2 of is the base. So you got to look at the picture, and in this case, the base is a triangle. It could be a trapezoid. It could be a square. It could be a rectangle. But okay? If it's a square or a rectangle, you're dealing with a rectangular prism, and those are easy. If it's a triangle or a trapezoid, that's when you have to do some work. Okay? It could be a circle, actually, because that would be a cylinder. All right. The volume of a prism would be area of the base times the height. So if the base is a trapezoid, you replace that big B with 1/2 base 1 plus base 2 times height of the base, then times height of the whole prism. Okay? So there's 2 different heights here, and you got to pay attention. One is the height of the base, and the other one is the height of the prism, if it's standing on a table.
What do you mean?
Okay, I said, if you're finding the area of the base, you find this first. That would be this height.
And then you find the long height.
And then if you're finding, once you find the area of this triangle in this box, then you multiply it by the height of the whole prism to see how many cubic units are in there. That's the most trouble that people will get into, is not knowing where to put the different heights. So what I like to do is I like to find this guy first and then multiply it by the height of the prism, okay? So your prism's going to look like this. It's going to look like that, like a piece of cheese. And then I multiply it by this height, okay? In this case, it's a trapezoid prism, which you're going to get on your homework, okay? The base would be the trapezoid. So let's say this is 10, this is 3, and this here, the height of the trapezoid is 5, all right? We find the area of the trapezoid, which we did yesterday, and that would be 1/2 10 plus 3, the 2 bases, times 5, okay? So that would be 1/2 13 times 5, which is 65, isn't it? It's 65, and half of 65 is 32.5. So that's the area of the base. You found big B. Now you multiply it, since the volume is big B times the H of the prism, you multiply it by this number here, and let's say that's 20. You multiply that by 20. So then it would be, volume would be the area of the base, which we found separately, times 20, which is 650. This was all feet, then it's cubic feet. Now a pyramid, you could have a square base or a triangular base. And what I do is put a dot up here and then connect all four sides. This one I can draw a little bit better, okay? And the height, I call the height of the pyramid the fireman pole. It hits the center of the floor. It's what would happen if you fell from the inside the pyramid in the ceiling all the way down to the floor, okay? That's the height of the pyramid. Well, if you look at a pyramid, it's 1/3 the area of the base times the height. This would be your height, and the base would be whatever the shape is. If it's a triangle, you put the area of a triangle. If it's a rectangle, you put the area of a rectangle. If it's a square, you put the area of a square. I did not include any pentagons or any weird pyramids, okay? So the volume of a pyramid is that the area of the base would be length times width of this. So let's say this is 6 times 4. And let's say the height is 7, okay? It would be 1/3 6 times 4, which would be big B, times the height, which is 7, okay? Now when you have pointy things, there's two pointy things we're going to be talking about today. Pyramids and cones. 1/3 is always part of the formula, okay? Because when you think about a little, remember, you know those pointy cones that you get like at the dentist's office to swish your, it looks like a snow cone? Well, if you take 3 of those, they look like this, and if you have a cylinder at the same height, it would take 3 of these to fill up that cylinder. Because they're pointy, so they don't hold as much water, okay? And that's where the 1/3 comes in. Anything pointy is going to have a 1/3. But guess what? You're going to have your formula sheet with you on the test and on your homework. So just look at the formula, write it down, and then plug in the numbers, okay? It shouldn't be that hard. So this is a cone, and this is a cylinder. Okay? So this is a pyramid. And the only thing left we have is a sphere. And the way I draw a sphere is I draw this like this, and this like this. And you can see it's kind of 3D. And the volume of a sphere has got a 4/3 to it, pi r squared. What is r, r cubed? What is the r?
The radius.
The radius. So they have to give you the distance from the center out to the side. If they give you that, you just plug it in there. You can gunk a pi, or you can put it all in your calculator using the pi button. Everybody see that?